What is a PLC? A Programmable Logic Controller, PLC, is an industrial solid-state computer that monitors inputs and outputs and makes logic-based decisions for automated processes or machines. How does a PLC work? PLC are a flexible and robust control solution, adaptable to almost any application. The PLC receives information from connected sensors or input devices, processes the data, and triggers outputs based on pre-programmed parameters. Depending on the inputs and outputs, the PLC can monitor and record runtime data such as machine productivity or operating temperature, automatically start and stop processes, generate alarms if a machine malfunctions, and more. There are a few key features that set PLCs apart from industrial PCs, microcontrollers, and other industrial control solutions. Input, output. The PLC's CPU stores and processes program data, but input and output modules connect the PLC to the rest of the machine. These input-output modules are what provide information to the CPU and trigger specific results. Input-output can be either analog or digital. Input devices might include sensors, switches, and meters, while outputs might include relays, lights, valves, and drives. Users can mix and match a PLC's input-output in order to get the right configuration for their application. Communications. In addition to input and output devices, a PLC might also need to connect with other kinds of systems. For example, users might want to export application data recorded by the PLC to a SCADA system, which monitors multiple connected devices. HMI. In order to interact with the PLC in real time, users need an HMI, or human-machine interface. These operator interfaces can be simple displays, with a text readout and keypad, or large touchscreen panels. The role of each PLC element. Input. The PLC monitors relevant data inputs and sends the data to the CPU. Some PLCs only use data inputs with discrete, on-off inputs, but PLCs with analog capabilities can accept analog inputs for continuous variables. Inputs may come from IoT devices, robots, safety sensors, human-machine interfaces, or almost any other type of data entry point. Logic programming. Every PLC is built with a microprocessor CPU, either 16-bit or 32-bit. The engineers and CPU technicians program help PLC recognize certain conditions and values and to make changes in the outputs based on its programmed rules. Output control. Based on the programmed logic, the PLC controls various switches, motor starters, relays, and other devices connected to its outputs. This allows the PLCs to take control of mechanical processes. Two main types of PLC. Compact PLCs. The compact PLC input and output are integrated into the microcontroller itself. Every type of input or output is fixed, so it does not have the capability to expand the modules. Modular PLCs. A modular PLC generally looks like a rack in which multiple modules can be fitted. This allows multiple expansions of the system and gives the PLC additional features such as an increased number of input-output units. Modular PLCs are usually easier to use because each component is independent of each other, meaning operators can troubleshoot by isolating modules. Advantages of using PLCs. Ease of programming. Advanced technology. Flexible costing. Rich functionality. Durable quality. Repairability. Energy efficiency. Drawbacks of using PLCs. PLCs have less capacity to handle extremely complex data or large numbers of processes. PLCs from different manufacturers often utilize proprietary programming software, which can create significant barriers to interfacing and interoperability between programming environments. PLCs are prone to electromagnetic interference, EMI, and common electronic issues like memory corruption and communication failures. How to choose the right PLC model. Electrical capacity. PLCs have different voltage requirements for their power supplies, so check to ensure that your selection is compatible with your electrical system. Processing speed. Check a PLC model CPU speed to determine whether it meets your application's needs. Compatibility. Ensure that your PLC model is compatible with any new or existing system hardware. Temperature tolerance. Most PLCs are designed for safe operation within the range of 0 to 60 degrees C. However, some specialized PLC models can operate at extreme temperatures. which is important for facilities with unusually hot or cold manufacturing conditions. Memory. A PLC needs sufficient ROM and RAM to execute the automatic processes. The controller uses ROM to store its operating system and instructions. RAM helps to execute its functions. Connectivity. Make sure your PLC has enough input and output ports, and make sure it's able to connect to the type of peripherals that your system requires. Analog input, output. Consider using a PLC with analog input and output mechanisms to manage processes involving continuously fluctuating variables.